Welcome back. In this video, we are going to just demonstrate what we learned in our previous videos about pointers and arrays and how they work together. So basically, I'm going to write program for these four things. First one, so let's start. The first one is passing array as an argument. Uh, okay, so for that, we need another function. So let's write that. So this function would do nothing but just print. So int n for size, and then what I would do is I would say 0 I less than 10 plus plus I, and then printf, and then p yeah %d space, and then p of I. Okay, and then let's add a new line just to make it look better. Okay, so new line here, and then let's define an array. Let's say 2, 4, 1, 5, 3. Okay, any random values, and then we are just going to call this function with our array and the size. Okay, so this is the first part. So we learned that the name of the array passes the base address, and that's what we are trying to do here. So when we are calling this print method, basically by just writing a, that means the base address of a would be passed here, and then this one is converted into, so p of I, as we know, like as I have mentioned it here, right? A of I is equal to p of I, which is equal to I of p and equal to I of a. So we are sure about a of I. I mean, this part we sure, like that's how we print an array if a is our array. We want to see like if p of I works and I of p works, and then if I of a works, that we can see. Okay, so let's try to do it like this. Okay, print. Let me copy this one, and then or let's do one thing. Let's copy this entire loop, and then instead of printing it p like p of I, let's try to print it like I of p. Okay, so that would validate what we learned in our theory video. uh, why this works, if you want to learn that, just refer to that theory video, which I can link here. Okay, so let's compile and see what happens. All right, okay, let me put a new line as well here, otherwise you would be confused. Okay, okay, now let's just compile it. Okay, no issues. And then as you can see, both these statements are working similarly. So both of them are printing 2, 4, 1, 5, 3. So that validates our theory, right? If you want to see if this one is also equivalent or not, so basically it would be, right, because a, if you just write the name of the array, it basically passes the base address, right, in case of one-dimensional array. So so a and p are basically pointer to the same location, as we discussed in our theory video, that a is just a constant pointer but p is not a constant pointer. So we can increment and decrement p, which we would see. All right, let's just quickly verify this part as well, I of a. So what I would do is, after the print, I would use the same similar loop here like this, but what I would do here is, instead of using p, I would use this a. Okay, and there is no n here, so I would just say 5, because n is equal to 5 anyways, n is the size. So let's see, now we have three print loops, like this one, another one here, and then another one here. All three should be printing the same thing, right? So let's see. Okay, and then so as you can see, 24153, all of them are like same, right? This is some garbage output, not sure why. Maybe we need to flush, but if I print this new line, it should be gone. Let's see. Okay, so it is gone, right? So yeah, so where we basically prove this part, passing array as argument, and then addition of an integer to a pointer, right? Because this one, okay, let's try to do slight modification now. P of I is internally converted into, we saw in our theory video, P plus I, right? So this is same. So we can maybe extend this one, and we can say that this is equal to star of, P plus I, and similarly, which is equal to star of uh, A plus I. Okay, don't get confused by this A. This A represents an array. Okay, and then addition is like addition is commutative, right? So what we can do is we can say that this is equivalent or equal to I plus P, and this is equal to uh, I plus A. So all of them are same, right? So maybe what you can do is, I'm not going to write and prove this thing. So what you can do is just extend this program, and then just see if all of them are same or not. Okay. All right. Let's move on. Yeah. So let me just verify another thing, which is how a pointer moves in an array. And by that I mean, if I add, so here we are keeping P is always pointing to the base address of the array, right? But what if we move it to next location? Like we said that if we increment its value by 1, it would be pointing to next location, right? Like plus plus P would point to the next index of the array. So is that true? Let's try to see. Okay. So now what I would do here is I would print P, and then what I would do is I would say plus plus P. Okay. Now let's see if this works or not. So yeah, it is also like behaving the same way, right? Why? Because as we mentioned in the theory video, if we increment the pointer, it gets incremented to a next location. And I mean, if it's and it so what value is added when I'm doing plus plus P? So just to mention here, P equals P, this would be like this, plus size of int multiplied by 1, because we are doing plus plus P. Okay, so this is equivalent to this. So we already said, right, we already discussed this, that whatever is the integer that we want our pointer to get incremented with, that gets multiplied by the size of the type of pointer, and in this case P is of type integer, so size of integer. All right. uh, if you want to see, like, you can see this by one more way, which is to by printing the pointer value. Okay, what does P contain? You don't need this bracket, so we can remove this extra bracket, and then let's print it in unsigned long. Okay, now let's see. Okay, hello.c. Okay, oh sorry. What is the issue here? Okay, it's a warning, so it's fine. We should be fine. It's warning because we are using unsigned integer, right? So let's try to print it. So as you can see, initially P was at some location ending in 088. Then on plus plus P, the next location was 092, and then 096, and then 100 and then 104. Okay, so if with every single increment, it is getting incremented by 4 bytes. Why 4 bytes? Because it's an integer pointer, right? And this is the logic of incrementing, adding any number, or like any incrementing the pointers, right? We also said that a is a constant pointer, right? Array, because array names are constant pointer, right? So let's try to prove that as well. So if I try to copy this one, and say I would try to do the same thing through this a. So instead of this p, I'm trying to use a. Okay. Let's see, would this be allowed or not? I'm just removing those comments because they're not required here. You got the point. Okay, so here we are trying to see if array name is a constant pointer or not. If it's constant, then this should not be allowed, right? So let's see if we get any error or not. Okay, so here's the error, right? So it should not be allowed. Clearly says like should not be allowed. Okay, there is other error as well, because n is not defined here. But if I remove that and compile, like there is this error, right? So cannot increment value of type int5, or this is the compiler's way of saying that this is a constant pointer. Okay, all right, moving on. What is the next example that we can demonstrate? Subtraction of an integer and subtraction of two pointers of same type and different type. So subtraction behaves the same way as integer, as the addition. So okay, let me see how can I write a short program to demonstrate that. uh, and we would prove one more thing here. Okay, subtraction of two pointers would prove that, so that's fine. All right, let's see how we can prove subtraction of an integer to a pointer. So it move same as addition, like it would move backwards uh, by same number of bytes as of its type. So let's see how can we do this. So for that, what I would do is p is fine. I would increment p, okay, and then I would subtract some value to it. So p equals, I'm saying p is equals p plus 2, okay, and then I am going to do, and then I'm going to print this address, okay. Let's see, printf, let's print both the address and the value, okay. So let's see, by address I mean the what p contains and what is the value at that value, okay. So p contains an address and what is the value at that address. So we want to print both of them. So first let's see, p, okay, and let's use sorry, %u and p. Okay, we have incremented p by 2, and let's see, let's also print the value to see what exactly on what index in the array p points after we add 2. So it should be pointing to 1, this second index. Okay, value contained at value present. This is kind of confusing. I mean, there is address. Well, when I say value contained, that means the address, and then I'm saying value present at value contained in p. So don't get confused. One is address, another one is value. Okay. And then what I'm gonna do is I would. So we want to see subtraction of an integer. So then I'm going to do p minus 1. Okay. and it should be, if our theory is correct, it should move to the previous location, right? So if it was pointing to the second index, which contains the value 1, now it should be pointing to 4, right? So let's see. And then same thing. Okay, let's try to validate if this is correct or not. We save this and then compile this one. Oh, okay, we have to remove this part because now this is another. Okay. So let me just compile it again, save it and compile it again. Okay, it's fine, the warning is fine. Okay, so I have to put a new line, otherwise it's not readable, very readable. So let me put a new line here, then like this. Okay, so once again, what we are doing, we are incrementing 2, then we are printing the address and the value, and then we are decrementing by 1, and we are trying to see if the pointer moves according to that pointer arithmetic formula or not, right? So let's see. So if you see, okay, let me add one more new line. I just copy it here. I'm sorry for adding so many new lines. This could have been added with previous printf, but it's okay. Okay, so let's compile it for one more time. Yeah, value contained in P, this is the address, okay? And then value presented, value contained in P is 1. Why 1? Because initially we incremented P by 2, so it would jump to 2 locations further in the array, right? So initially P was pointing to this 2, and now it jumps to 2 locations, so 1 and 2, it's now pointing at 1. If you want to understand the theory, you can refer to the previous video, the theory video basically on integer, on pointer and arrays. And then what we did, we decremented it by 1, we subtracted 1, and then we are again printing. So you see, this one was ending in 408, so it's 404, everything else is same in these addresses, so it jumped back 4 bytes, which is correct according to our theory, and then value presented, that value is 4. Let's see, yeah, so the value is 4 before 1, so that's fine. Okay, so this proves the third one. Last one, subtraction of 2 pointers of same type and different type. All right, subtraction of 2 pointers of same type, what would that give? So we know that that would give the number of locations in between those 2 pointers. Okay, so what I would do is, our P is here, what I would do is I would create another pointer, P2 here, which is, it's P minus 1, which is pointing to previous location. And now what I would do is I would just subtract both of these and see what is the result. Okay, that's all. Too many print statements. Okay, and this one is fine. We'll keep 1. Okay, so let me write it this way: P2 minus P equals how much? We'll just do this, P2 minus P. Okay, and this should be 1, right, according to our theory. So let's see. Let's try to compile this. Okay, sorry, again I missed this one, so let's do %d. Okay, should be some warning because I think it expect a long value, but let's see. Yeah, so it wants %ld, but that is fine. We know it's not going to be a long. It can be typecasted safely into an integer. So, oh, P2 minus P is minus 1, and why is that? Because P2 is a lesser value now, right? So we have to do P minus P2 if you want to see the positive one, right? Because P is ahead, and then P2 should be the lower address. So for a positive value, we have to do P minus P2. but I think this works as expected, right? See this. So this is 1. What if I do p minus 2? So this should be 2, right? Yeah, 2. If you want to remove the warning, just do like this, %d, and that would remove the warning. See, warning was gone. Okay, so p2 minus p is 2. All right, if you, again, I'm saying I'm repeating this again. If you want to understand the theory, you can refer to the theory video of arrays and pointers. Okay, what about subtracting two different types of pointers? Uh, can it work? No, it won't work, right? Because on what logic it would work? Like, we know how subtraction works, how subtracting an integer to a pointer works, but if the pointers are of different type, then there is ambiguity in the compiler, right? So it and compilers doesn't work on ambiguity. It has to be concrete. So let's try. I can write a program to see it fails. So let me change the name, validate, and we don't need all of this now. So what I would do is, to validate this, what I would do is I would take an integer variable and I would take a pointer variable, okay, which contains the address of a. Then what I would do is I would take a char variable, okay, char c h equals let's say a, okay, and then I would take a char pointer, okay, char pointer cptr, which points to the location of ch, right? And now what I would try to do is so let's not print because it won't work anyways. Let's just do this. P minus cptr. Okay. See if this works. Int val equals p minus cptr. Okay, let's see if this works or not. So let me call this function here in main validate. All right, let's see. Let's compile this. The compilation would fail. So as you can see, int star and char star are not pointers to compatible types. So that's why this won't work, right? Okay. I want to demonstrate one last thing, and which is about character pointers. So there is something special about character pointers. What is that? Uh, if I do something like this is a string, right? Hello. Can you tell me, like, this is an array, right? A character array, basically. In the memory, it would be something like this. So H would be stored, then there would be E, and then there would be L, right? And then there would be another L, and then there would be O. Anything else? Yeah, because this is a string, and we have not yet covered string, but I can create a separate video on strings, but every string ends with a null character. What is a null character? It's \0. Okay, so this is how hello is represented. Okay, so uh, just wanted to, like, that is the difference between an integer array and a character array. If it's a string, if I initialize it like a character by character, then the null character is not there in the end. What do I mean by that? So if I initialize it like this, equals, like this, I'll just copy this one and I'll just remove this part. Okay, so this is what it was. So, and then we can use all the similar things. I mean, all the pointer uh, concepts hold true for both of them. It's just that when it's a string, there is one extra character at the end. That's what I wanted to show. Okay. All right. I think that's it for this video. Thank you so much.